Hey Josh. So this here is the review for chapter 5. I'm going to attach a blank copy of this review sheet as well as a copy of the test. Now you can fill out the blank copy of the review sheet and follow along with this video as I go through how to answer these questions. And then when that's finished, what you can do is open up the test file, answer the questions on a sheet of loose leaf, and then send me a picture or a photocopy of the test that you've completed, and I'll correct that. The test will be identical to this review, except the numbers will be different, but the questions will be asked in the exact same way. So I'll get started. Your test is going to have 2 multiple choice questions, just like this review. Question 1 and question 2 will be multiple choice, and it'll even be the same type of multiple choice questions. So when I show you how to solve these, you should have a good idea of what to do on the test. Question number 3, we are finding out if we have a function, and if it is a function, if it's a linear function, how can we tell? I'll go through that. The question on your test will be the same, except again, the numbers will be different, and maybe one of these will be a function on the review, and it won't be one on the test. You'll have to figure that one out. Question number 4, you're going to draw a diagram representing a situation. I'll go over how we do this and then label it. And question 5 is a bit of a word problem that involves you selling t-shirts and how much money you make from selling the t-shirts, and we'll go over that. Let's start with question number 1. So question number 1, we have how many of these equations represents a linear function? So if you remember, a linear function, it's going to have an x and a y, or just a y. It can't have either an x squared or just an x, and I'll explain why as we go through them. So for this first one here, y equals negative 2x plus 7. That one there, I can say, this one here highlighted in red, we can say is indeed a function because we have an x and a y. X is to the first degree, so this would create an oblique line. This one right here, y equals x squared take away 5. So this one here highlighted in blue, because we have a second degree term, meaning we have an x squared. Remember, this x on its own is a first degree term. X squared is a second degree term. We can say that this one here is not a function because it has a second degree. Sorry, this one here is not linear. It is a function, but it's not linear because it has a second degree term. And just so you're aware, if we look at this next one that I'm going to highlight in green, f of x equals 3x squared take away 8. Now this one here has the symbol f of x. Remember, don't let this throw you off. Whenever you have something like f of x, or you might see something that says g, oh, not of f, g of x, these are really just another way of saying y in the equation. The same way we have y here, we have a y here. F of x or g of x is just another way of writing y. This indicates that we know for a fact it's a function when we have this particular notation, but I could have just as easily replaced that g of x with the letter y, and it's still the same. However, because we have an x to the second degree here, x squared, I know for a fact this is not a linear function. It is indeed a function, but it's not linear. And finally, I have x equals 12. And if you remember what I said earlier, we can't have a linear function with x equals 12. So this one here highlighted in yellow is not a linear function. And the reason for that is if I have a graph and I have x is equal to 12, what that's going to give me is where x is equal to 12 on my x-axis, I'm just going to have a straight line that will come up through my x-axis. So that would mean it will not pass the vertical line test. Remember the vertical line test from earlier in the unit? In order for it to be a function, you can't have a vertical line hitting your graph line in any more than one spot at a time. And since my vertical line here completely covers that vertical line, it is not a function. That being said, if we had this y is equal to 12, what that would create is a horizontal line that would go like this, straight across. Make that look a little neater. So in this particular case, the blue line I just drew, which is represented by y equals 12, that there would pass my vertical line test. So that would mean it would be a function if it was y is equal to 12. So y is equal to 12 would be a function, but x is equal to 12. Oh, I put the wrong symbol there. That shouldn't be a check mark. That should be an absolute x because it is not a function. So how many functions do we have? We only have one. So the correct answer in this case would be A. Only one function. Now for number 2, for the function f of x equals 3x plus 1, what is the value of x when f of x is equal to 10? Now, when they say f of x is equal to 10, that's basically them saying y is equal to 10. If they had said x is equal to 10, I would have to replace this x right here. But since they're saying f of x is equal to 10, I replace f of x in this equation, and then I just solve for x. So I can rewrite that equation. F of x equals 3x plus 1. I replace my f of x with the value we have right here that I'm going to highlight in blue, 10. So f of x is equal to 10. So 10 is equal to 3x plus 1. So now if I solve for x, I would subtract 1 from this side, which means I also have to subtract 1 from that side. That leaves me with a 9 on this side. And this plus 1, subtract 1 will reduce out. And I'm left with 3x is equal to 9. So now in order for me to get x on its own, which is my goal here, I need to divide this side by 3, which means I divide that side by 3. So what that leaves me with is 3 is equal to x. If I look up here at my answers, well, now on this review sheet, this was a typo. On your test, this typo will not exist. The answer is not supposed to be 31. I will scratch that out because that 1 is not supposed to be there. That was a typo when I was making the review. So 3 is indeed one of our possible answers. So in this case here, the answer is also A. Okay, so there's 1 and 2 done for us. So question number 3, you're going to definitely need to write this out on loose leaf or on the back of the sheet if you have it printed, because you're going to need to fill in a lot of this information. Now on your test, it's going to be a little bit more streamlined. Again, this was due to numbering. These shouldn't be numbered the way they are. Number 1 and 2 are fine. State whether it is a function. If it is a relation, or if the relation is a function, then state the domain and range. That's fine. But it shouldn't say 3. State whether it is a linear function. Oh, so that is there, yeah. But this one here, if it is a relation, so this doesn't need to have a number by it. So this here shouldn't have a number by it, which means this here should be 4. This one here should be 5. So there's 5 things you're answering, not 6, for each of these questions here. So we have 3 different ways of displaying a relation or a possible relation. So we have a table of values, we have a graph, and then in this one here, we have a set of ordered pairs. So I'm going to start with the table of values, and I'm just going to take the table of values, a copy of it right here for A. We'll move it over to the side so that we can make our answers. So I don't want to move too far off, but A will go right here. So when we look at the questions we're being asked, is asking, state whether it is a function and how you know. Okay, great. So in order for this to be a function, remember, we can't have any repeats. We can't have any repeats right here. So we can have repeats over here, that's fine, but we cannot have any repeats in our x values. And since we go 2, 4, 6, 8, and there is nothing that repeats, then we know that this is indeed a function. So this case here, we can say, for point number 1, state whether it is a function. Yes, it is a function because each input has one output. In other words, you don't have any inputs repeating. Remember, your x values would be what we would call input values. Your y values would be what we call output values, which is going to help us answer another question in a moment. So there's number 1. Now for number 2, A number 2, state the domain and range. So in these ones here where we have a table of values, the domain and the range are literally just the values for x and the values for y, and we just have to list them. So for number 2, first we're going to talk about domain, and that is just the values of x. So in this situation, make a bracket, make a better looking bracket than that. We have 2, 4, 6, and 8. And then there's our domain. Our range is just going to be the values of y. So in this case, 6, 3, 0, -3. And the range is done. Now, number 3 state whether or not this is a linear function. So in order for this to be a linear function, we have to have a constant rate of change in both our x value and our y value. So if I look at my x value, every time I move from one value to the next, I'm going up by 2, plus 2, plus 2. So this rate of change in my x values is constant. It's constantly going up by 2. Now when I do the same thing here for my y value, I'm going from here to here, that was going down by 3. Then from there to there, I went down by 3 again. Then from here to here, I went down by 3. So my rate of change in my y value is constant as well because I'm going down by 3 each time. So for question number 3, state whether it is a linear function, how you know. Yes, it is linear. Yes, it is linear because x and y have a constant rate of change. So there you go. They have a constant rate of change, so that's how I know they are linear functions. Okay, so now number 4, since we know it is a linear function, identify the dependent and independent variables. So this is what I was talking about earlier when I said input and output. Your input values are always your independent variables. Your output values are always your dependent variables. So in this case here for number 4, so for number 4, X is the independent and Y is the dependent. And now it's asking us to determine the rate of change. And we kind of already did that when we answered number 3. Because the rate of change, for number 5, the rate of change in a table of values is how much the Y value is changing over how much the X value is changing. And then later on, we'll learn another word for this. It's called slope. But for now, the rate of change, rate of change equals, well, in this case, we have a -3. That's how much our Y value is changing by each time. So it's going to be -3. And now it's always in fraction form. X we have going up by 2 each time. So the rate of change is -3 over 2. I say it's always in fraction form, meaning we should always think of it in fraction form when we talk about rise over run. We'll get into that in the next unit. For this particular case, if you had wanted to do this and turn it into a decimal and give me -1.5, that would still technically be correct. So there's number 3A done for us. And again, like I said, you're going to need to fill this stuff out on a sheet of loose leaf, but I think that shouldn't be too much of a problem. So now I'll do B, and in B we don't have our table of values anymore. We now have this graph and its distance over time. So that alone should tell us some information. So I'm going to take this graph over here off to the side. We'll answer those exact same 5 questions that we did for the table of values. So if you're looking at your sheet, you can read them as I go through them, but I'll come back over and look at them from time to time over here as well. The first one is state whether it is a function and how you know. Okay, so in this particular case, when we're talking about a table of values, we had to look at whether or not the X value was changed or had any repeats. When we're looking at a graph, we have to look at our vertical line test. This line that's on the graph passes the vertical line test because at no point in time is this line on the graph passing through my vertical line at any more than one spot. So for B number 1, is it a function? Yes, because it passes the vertical line test. Number 2 then is asking us to state the domain and range. So in this case here, we have a very specific domain and range. Because this line has a starting point and an ending point, we can give the domain and range as a specific, within a specific parameter. So let's start with the domain. Remember, the domain is all the possible X values. And since this line representing time with the variable t is what we would consider our x-axis, because it's a horizontal axis, we can see the lowest value that we have for this line in terms of x is 0. And the greatest value that we have in terms of this line is 20. So in this situation here, for number 2, when I go to do my domain, I put my bracket in. Oh, it's an ugly bracket. I'll try one more. A little better. Okay. So in this case here, I'm going to state that 0 is less than or equal to, and it's equal to because this is a solid dot, not a hollow dot, less than or equal to t. If you said x here, I wouldn't mark you wrong, because technically we're talking about x and y. But since they gave us, in this case, the variable t, I'm just going to use t. But you can use x. I won't mark you incorrect if you use x. And we know that t has to be less than or equal to the greatest value here, which is 20. So I put 20 right there. So my domain is all the values between 0 and 20. So t can go as low as 0 or as high as 20. Now, when I think of my range, it's the same idea, but we're just looking at our y-axis, which is right here. And they have it labeled d because we're talking about distance and time. So in this case here, my range would be all the values of the y-axis labeled d. So the range is, again, starting at 0 because that is the lowest value here. And the highest value you can see is 100. So 0 is less than or equal to d. And again, if you want to use y here, that's perfectly fine. That would be completely acceptable. Which is also less than or equal to 100. Because that is the highest value for y. There we go. So now, number 3, state whether it is a linear function and how you know. Well, this image right here is of a straight line. So a straight line would be a linear function. That's all we need right there. So we can just say it is a straight line, so it is linear. There we go. Now, number 4, identify the dependent and the independent variables. And since we know all the x values are independent and all the y values are the dependent, in this case, for number 4, I'm going to say that the time, because that's what we're talking about here, time equals independent and distance equals the dependent. And then number 5, the rate of change. So the rate of change, I said earlier, another word we're going to learn for that is slope. And it's how far you travel on the y versus how far you travel on the x. So in this case here, it's going to be in a fraction form. And this line is starting at 100, and it comes all the way down to 0. So we went down by 100. And then we started here, and we went all the way to the right by 20. So we now want to do negative 100 divided by 20. So negative 100 divided by 20 is going to give us a negative 5. So our rate of change is negative 5. Now this next one, oh that's following me. I'll put that there too. Okay, so now this next one, part C, is actually going to be pretty simple. In order to find out if this set of ordered pairs is indeed a function, we then need to make sure that none of the values for x, so remember, just in case you don't remember, the first number in these order pairs represents x, the second number represents y. So we cannot have any repeats in the x values. That just, the y values can have repeats, but the x values cannot. So if we have any repeats in our x values, then this is not a function. And if I look closely, I can see right here, I have a positive 1 there. I also have a positive 1 here. So that alone tells me this is not a function. But it's not just there. I also have a positive 3 there and a positive 3 there. And I have a positive 5 here and a positive 5 here. So since we have all of these numbers repeating in the x value, we can say right off the bat for C, not a function. And because it's not a function, we don't need to do number 2. If the relation is a function, state the domain and range. Well, since it's not a function, we don't need to do that. State whether it is a linear function and how you know. But again, since it's not a function, we can't state that. If it is a linear, or if the relation is a linear function, state the dependent and independent variables. Again, we cannot do that. And we cannot determine a rate of change because this is not a function. So all we need to do for C is write not a function because we have repeats in the x value. Okay. Number 4. So number 4 says, describe a situation that could be represented by a distance time graph. Now, we could use something like this that we already saw, but I'm going to show one a little bit more in depth. Draw the graph to represent the situation, then explain why the graph represents the situation. So I'm going to show you a very basic one that we can draw. And I believe that if you stick with this basic situation, you should be just fine. So the first point I'm going to make is right here. I can make another point up to here, make a point to here, and then another one down to here. Now I'll label this. We'll say this here is 1, this here is 2, this here is 3, this here is 4, this here is 5. Maybe we'll label this 1, 2, 3, 4. This will be distance. This can be time. And I'm going to connect my dots. I'll label my dots too. This here will be 0. This will be A, B, and C. And now all I need to do is make up any situation at all to describe what could be happening between 0 and A and B, and then B and C. So if I say that my time here is in minutes, and maybe the distance could be in something small, feet, or you can make it large. Again, this is going to be a situation you decide. Here, from point 0 to point A, it took 2 minutes to walk 3. Maybe feet would be a little bit too small of a unit for this one here, so we might go back and adjust that one to meters. Still not great, but there we go. So if I was just to describe from 0 to A, I could say something along the lines of Mike walked. In this case, I would have walked 3 meters. 3 meters in 2 minutes. Then from A to B, my distance isn't changing, so I'm not moving anywhere. Then, so you could say Mike rested for 2 minutes. Then from B over to C, you can see that it took 1 minute from 4 to 5 to travel back that same distance. So we can say, Mike walked back 3 meters in 1 minute. And there you go. Number 4 is done. That's all there is to it. You had to draw this graph and then describe it right here. So you can make it as simple or as complicated as you like. I recommend making it as easy on yourself as possible, just giving yourself a simple situation, but it's up to you. So now number 5. So number 5, there's going to be some things that I'm going to need a graph, so I'll do that off to the side. If you have graph paper, great. If you don't have graph paper, just do a rough one on a sheet of loose leaf as best you can. I'm not really going to mark you on preciseness, just as long as it looks the way that it should. So in this case here, we have a situation. This table of values shows how the profit for the sales of t-shirts relates to the number of t-shirts sold. The number of t-shirts sold is 0, 1, 2, 3, 4, 5, 6. The profit is minus 24, minus 18, minus 12, minus 6, 0, 6, 12. So what does a negative profit indicate? And in this case here, when you have negative numbers, this would indicate that you lost money or you have negative money, or you could say you're in debt or lost money, because that's what happened. Now for B, it says to graph the data. So we have our table of values right here. So I will make a rough graph off to the side here. Make y-axis. And we're starting all the way down here at a negative 12. So I'm going to go, or negative 24. Then we have negative 18, negative 12, negative 6, 0, 6, 12, 24. The x-axis will go right through here at 0, and we'll say 1, 2, 3, 4, 5, and 6. I need to go over to 6, okay, and 6. So now I'm just going to plot where those ones, so I have 0 and 24, which would be all the way down here. Then I have 18 and 1. Then I have 2 and negative 12, 3 and negative 6, 4 and 0, 5 and 6, 6 and 12. So again, I just did a rough graph by hand. I didn't have any graph paper. So if you don't have access to graph paper, I'm perfectly happy with you doing something similar to this. It's a rough graph, but we get the idea. We're starting down here when we have 0 shirts at negative $24, probably because it costs this person $24 to get the shirts made. And then if they're selling them for $6 each, boom, 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 boom. We can see that slowly but surely as they sell their t-shirts, they break even right here, and then they start to make profit. So in this case here, identify the dependent and independent variables. So for D, in this case here for D, I'll write, I'll just write it next to, actually I'll just put D right here. D, we have P is equal, no, actually we'll do it the other way around. We'll say N, which is the number of t-shirts sold, is our independent. And P is the dependent. Great. So now, this next one, E, determine the rate of change. So, and what does it represent? So for E, remember what we did the last time we had a table of values. We look at how much it changes in our x. So this one here for x, every time we go over, we're going up by +1. And every time we go up here, we're going up by +6. So the rate of change oh, actually I got these mixed up. I got this one here should be C. So that should be C, and technically D is determining the domain and range. We'll do that in a moment. So E is the rate of change, so rate of change. And that's going to equal how much Y is changing, which is 6, over how much X is changing, which is 1. So 6 over 1, or if you just wanted to write it as 6, because 6 divided by 1 is just 6. So there's our rate of change. Now, the domain and range. So for this one here, for C, the domain and range, or sorry, D, I keep saying that. For D, domain and range, the domain is all of the values of X. So we have 0, 1, 2, 3, 4, 5, 6. And then the range, I'll do a better bracket, is just -24, -18, -6, 0, 6, and 12. Now F, suppose the table is extended, what profit would a sale of 75 t-shirts make? So now we need to kind of put together a way of making an equation out of all this, if we can, because I don't think they're gonna extend the table till we get to 2075. That'd be a really long table. So since I know that we want to make a profit, so that's gonna be, I'm gonna answer E right here, or sorry, not E, F right there. So F, we know that profit is going to equal, now in this case here, we know that we're making $6 off of every t-shirt sold, so $6 times the number of t-shirts sold. And when we had 0 t-shirts sold, we had -$24. So that's the equation we want to use in order to solve. So if we know the number of what profit on the sale of 75 t-shirts, so the profit is going to be 6 times 75, take away 24. So 6 times 75 is 450, subtract 24. So the profit on 75 t-shirts would equal, in dollars, $426. Now for G, it's asking us what kind of profit would we, or how many t-shirts would we have sold if we had $456. So we can use that exact same equation for G. And it's going to be profit is equal to 6n take away 24. And now if I know that the profit I made is 456, now I want to solve for n. So I'm going to add $24 to this side, which means I also have to add $24 to this side. That will reduce both of these out. And on this side here, I have 480, and I'm left with just 6n on that side. So I will divide this side here by 6, divide that side by 6, and I wind up getting 80 equals n. And that's the last question. So if you're able to do that, then you should do just fine on the test. Hope that was helpful. Thank you very much.